Mm-hmm. Okay, and welcome back to Learn to Code. Well, this is Learning to Code. There we go. Let's share on LinkedIn. LinkedIn. How do you pronounce that one? I don't know. Yeah, why not? There we go. Okay, we are online. Well, today I'm going to be continuing with my learning process. I'm going to be learning Python. Let's change into. There we go. Okay. I see I have some updates here. What would you? I wonder if there is a difference between updating from the pop shop and whatever apt update is going to do. Let's try to update from the graphical user interface for today, I guess. And okay, I guess I should leave this one here. It's not asking for root access or any of that, so okay. I don't think so. So last time I was working on object-oriented programming chapters. Oh wait, yeah. By the way, recently I bought this course. I haven't watched it yet. It's from Maximilian Schwarzmüller, one of my favorite JavaScript teachers on Udemy. Me and my wife study under Angela Yu first on her bootcamp, and then I moved into Maximilian's Node.js course. And in my opinion, Maximilian is more it goes deeper. Yet I think that he's more like a tutorial-based teacher than an actual teacher. So it's pretty much a trial by fire here. But anyway, although I think I had used a better teacher, I know that Maximilian knows the material better, may I say so. I think that that's because maybe he's working what he teaches, so that's why he's presenting things that that I don't have to discover by myself. Basically, that's not the case with Angela Yu. But anyway, I bought this course because you may not know this, but I am very old school while I'm working creating software. And this idea of automatic testing and unit testing is pretty much a novelty for people my age. And basically, I'm wanting to find a course that basically teaches me this. I found one, and I downloaded one years ago from Simon Allardyce when this is back in 2015, I believe, when lynda.com was a thing. So I was able to download and preserve for the future the unit, the test-driven development course on lynda.com, and I learned a lot about that. He works with Java, and we see examples with JUnit, but I understand, because he explained on that course, that basically unit testing is this general practice that you may apply on any other programming language. Basically, there is in the case of Python, for example, we have PyUnit, In the case of Node.js, I don't know what it's going to be called, but basically .NET, we have NUnit and so forth. For C unit, we have for C, and the thing is that unit testing is pretty much generic. You can implement it in every single programming language out there. I see that the artificial intelligence is having a hard time trying to decide if my green shirt is going to appear on the shot or not, but I don't know. Anyway, it looks like it's doing a great job so far. I see some transparency with my shirt, but it's not too bad actually, considering I don't have a green screen behind. Maybe I should put one which defeats the purpose of setting the artificial intelligence instead of having a green screen. But anyway, not right now. Well, I'm going to be watching this course later today. I'm going to continue with the Complete Python Developer course over here. Seems like it reads in 2022, but really this course I think is at least 5 years old. And this is a thing with Udemy courses. I never really trust when a course has the current year there, because it's pretty much a lie. But programming languages sometimes don't change enough that you actually need to buy the newest one. Most of the time, whatever you learn on these programming language courses is going to be useful in the future, so you don't really need to worry too much about it. But frameworks and library courses, those are another animal altogether, because updates in frameworks really matter. So and it happens to me once when I was working with AWS, building a RESTful API using Django, and the course about Django was Django version 2 or version 1, I don't remember, and the new version was Django version 3 or something like that. And right off the start, I was having issues trying to solve the exercises and the examples, because the Django framework changed too much, and the videos were not relevant at the time. But anyway, that's another story for another time, I guess. Okay, so I guess I may like to rewatch the developer fundamentals, encapsulation, and because it seems like this chapter is pretty big. It's 2 hours, 3 minutes. And I believe that, just to recap, I'm going to replay this one here. Oh, wait.
Welcome back to another developer fundamental. What is it? It's to test your assumptions. What do I mean by this? Well, anytime you learn something new, maybe something I'm teaching you, or something other instructor or book or resource is teaching you, you want to test your understanding and your assumptions. Because you don't want to have any magic black box that things are happening that you don't understand. You want to know how things are working so you can explain it to people. For example, remember how I said that self is referring to this player character class? How can we test this assumption with code? Well, if I had just learned what self is, what I would do is to say to myself, well, I want to see self. I want to know what it is. You know what? I'm going to return here self and actually see what's going to give me, right? It's code. I can return self if I want to. Well, let's do that. Let's create this player character. Yes, I'm 100 years old. And then here we'll do player.run. Let's do a print here and click run. All right. So the self is the player character that I created, which is
the entire object. Okay.
Okay. So although this is a simple example, what I'm doing as I'm learning is to test my assumption. Is that what I expected? Before I even run this code, I like to think in my head, what do you think is going to happen? And if there's a mismatch and I get something returned that I don't understand, well, then maybe I look into it. For example, this underscore main. I still don't really know what this is. Why is this here? I mean, it has to be there for a reason, right? And that's something that we're actually going to talk about later on in the course when we talk about modules. So hang in there. But the way that learning happens in an accelerated fashion is when you don't just take my word for it. Because if you do that, you don't fully grasp the concept. The idea is to test and test yourself as well in your understanding. And say, if my assumption is that self is referring to the object that we create, how can we test it? And this is a great skill that a great programmer has. So hopefully in future lessons, when I'm teaching you something, you test those assumptions. You test your learning through methods like this. I'll see you in the next one. Bye-bye.
Yeah, okay. That's the introduction video.
Into those boxes that can be used.
Oh, wait.
And
That's
also
not...
right? Because welcome back.
There we go.
What I haven't told you is that when learning about object-oriented programming, again, and not just in Python, but in any programming language that supports OOP paradigm, is this idea of 4 pillars of OOP. The 4 things that object-oriented programming does really, really well. And as a matter of fact, we've actually learned the first one. And that is the idea of encapsulation. What is encapsulation? Encapsulation is the binding of data and functions that manipulate that data. And we encapsulate into one big object so that we keep everything in this box that users or code or other machines can interact with. And this data and functions are what we call attributes and methods, right? We're able to encapsulate the functionality of a player character by having name and age data or attributes, and also have functions that can act upon this name and age. So for example, I can have a method in here that says shout or speak. And the speak method can now use the name and age. I can say, my name is self.name, and I am self.age years old. So that if I do player1.speak, and I run this, my name is Andre, and I'm 100 years old. I'm encapsulating the functionality. If I didn't have this class, I would have, well, some variables and then 2 functions. But by using encapsulation, I've packaged this up into a blueprint that I can create multiple objects of, so that when other people see my code, they know, hey, this is an entire object that I can interact with, I can use in certain ways that player character describes. And we've also seen this in our built-in Python data types, right? When I create a string like this, because of encapsulation, I have all this functionality available to me, all these methods that I can access. So that if I do, let's say, capitalize, it will capitalize all my strings. I have all this functionality encapsulated for me to use. Now, why do we want to package data and functions into attributes and methods? Well, because this gives us extra power, right? If, for example, this player character doesn't have any actions, any methods, and just had attributes, well, in that case, this is kind of like a dictionary, right? It's kind of useless. If I print player1 here, and I click run, I have this player object, but I can access name like this, and I can also
Because it's public, yeah.
like this.
All those attributes are public.
To it. I could have the same dictionary here, let's say player2, that is going to equal a dictionary that has name of Andre, and then age of 100. And the only real difference between the two is the way I access this information. Instead of the dot notation, I use the bracket notation to access the keys. So that when I click run, I have to make sure that I do 2 here for player 2. If I click run, again, it's the same thing. Sure, I can do it this way, but it's kind of useless. Why not just create a dictionary if all I want is data? But using this way, I'm combining things, packaging things up into those instances, into those boxes that can be useful. And also things that have meaning, right? Because our world is full of data and actions, right? Even a tree, for example, if we had a tree class in our real world, the tree would have maybe whether it was an evergreen or a perennial. It'll have whether it has leaves or it doesn't, how tall it is. It'll have all that information, but also actions, right? I can cut down a tree, the tree can grow, the tree can extend its roots. So this way, we're able to mimic what happens in the real world with our code. So that is encapsulation, and we've seen it. But let's talk about our second pillar in the next video.
Abstraction, okay.
We know that there's 4 pillars of OOP, and we learned about encapsulation. What's the second one? Well, it's called abstraction. And abstraction means hiding of information, or abstracting away information and giving access to only what's necessary. So whatever the user or the programmer or the machine is interested in, that's the only thing we give access to. Everything else, we kind of hide it in a blanket underneath the hood because our users don't have to worry about it. Let me show you what I mean. If I go back to our old example here, so instead of having a dictionary, we actually have a player character with a bunch of methods. Now, abstraction can actually be seen here, right? When I do player1.speak, you're seeing abstraction in action. Because when I click run, I get this string, but when I call speak, I don't really care how speak is implemented. All I know is that player1 has access to the speak method, and I can use it. Same with when I'm using something like a tuple, right? If I have 1, 2, 3, and I do dot here, I can do count to count how many items are in the tuple. So if I do print and click run, well, I have to give it a thing that we're looking for. In our case, let's look at 1, and let's add another one in here. If I click run, I get 2. Now, do I need to know how the count method was implemented? No. I can go look into it. I can look at the Python documentation, maybe the Python code, and understand how it's actually counting this, but I don't really need to, right? If we try to understand every single little piece, our head's going to explode. Sometimes all we need is a method or an attribute and just get access to it without having to worry about how it's being implemented, which is really, really nice. The same goes with built-in functions, right? If I do length here and I click run, I get a length of 4, but I don't really need to know how length was implemented in Python. It's abstracted away from us. And this is the power of OOP. It abstracts away things that we don't need to care about, or at least it makes us more efficient so that we know that it works a certain way and we're not wasting our time learning or coding from scratch. If we had our iPhone, for example, well, the camera feature on an iPhone, it'll be nice for an app that we built to use it, but we don't need to actually know exactly how the iPhone camera is coded on an iPhone. No, instead, the iPhone usually gives us a way to say camera.take picture to actually allow us to take a picture without knowing how the Apple engineers actually coded the camera. So it's a very powerful concept. Okay, so you're thinking, I think I get abstraction, but let me ask you this. Could I just do player1.name equals to, let's say, exclamation marks, and then player.run? Or you know what, let's do speak equals to boo, make sure it's player1. Well, if I now print and do player1.speak, and I try to run this function, let's see.
It's
Again,
not.
string object is not callable because speak has been modified. Speak has been modified to a string value instead of this actual function that we would have needed. So that if I run just checking the speak attribute,
That's even horrible.
I mean, abstraction is good.
You're
but hold on.
destroying an entire
If I have a
method.
class that I've abstracted away, but
Yeah.
anybody can come along, any programmer can come along and just
Yeah,
remove all my hard
just
work and
remove.
overwrite it like that. Isn't that bad?
Yeah,
We can
that's
explore this topic a little
horrible.
bit more in the next video.
I seen that with attributes and lazy programmers said
In the previous
every
video,
single
we
attribute
did
is
some
public,
basic
but
that is, we overwrote
functions
name and
themselves,
speak,
wow,
and now all
that's
that hard work
going
that we
way
do in our
too
class
far.
has been overridden by this. I mean, sure, if we instantiate a new object,
This is an important one.
we will have our run and speak,
Yes.
but player one now is completely useless. It has no name and speak, well, it just says completely useless. Now in Python, there's this idea of public and private, and this is related to our discussion of abstraction.
And in any other programming language for that matter.
We give access to things that a user is concerned about, right? So ideally, we shouldn't have access to init. Ideally, we shouldn't be able to, let's say, modify run or modify name and age, because when we create a player character in our game, hopefully the player can just randomly change their name or their age and sneak into our game that perhaps is only 18 and over. So can we make a private variable in our class? Well, here's the thing. Some languages allow us to have private variables. For example, in a language like Java, I can actually say that an attribute is private like this, and I won't be able to access it and modify it like I have this way. But
Okay.
in Python, there's no true privacy, no true private variables. So how do we get around this? Well, what we would do is do underscore name or underscore age.
What?
Does this give any special power? No, this is just a convention. That is, as programmers, as Python programmers, we determine that, hey, if we see underscore in our code, that most likely means that this should be a private variable. So that when I use it in speak, let's say underscore name, underscore age, and let's comment this out. If I click run,
Yeah, it's, going,
well, I have to run this because now it's a method. Let's go.
yeah, it's a method again.
And I get, my name is Andre, and I'm 100 years old.
Yeah, it's the
It
same,
all
but
works. But if I try to overwrite these and click run, oh, and now because it's no longer a
no,
method, let's
not
remove speak,
longer a
and click run,
method.
this still works. And that's because, like I said, there's no true private variables. As
Wait.
programmers, we've decided that underscore means that you shouldn't touch this. Please don't touch this. You can still be bad and do something
What?
like this, but I'm letting you know ahead of time. If you see underscore,
It's
this
not
should be modified.
enforced.
It should be private. And that's how we achieve privacy in Python. We all kind of agreed to say, hey, let's keep this little thing private.
Wait,
If
what?
you ever want to keep a method or an attribute private, you just put an underscore in front of it, but it's no guarantee. What about this double underscore init? Again, this is
Yeah.
something we're going to be speaking about very shortly, but it's called a dunder method. That is, it's built into Python. And we usually never write our own dunder methods. We would never write double underscore like this. These double underscores, and there's lots of them, have special meaning in Python. And the reason that they're named like this is because they're saying, hey, if you're writing double underscore for your variable, you're doing something very wrong. You're about to overwrite something. So once again, this double underscore is also a convention to let people know you shouldn't really touch this
Convention.
or
Oh
modify
my
this.
god.
Each data type, let's say a list, if I do dot, you'll see that as you scroll down, you have a lot of these dunder methods. Again, something that we're going to talk about. But these are here to let you know, don't overwrite these. If you're doing something like underscore underscore, I don't know, doc, like this, that's bad. Don't try and modify it and assign it to 5.
Oh my
So
god.
this idea of a private field is important to Python. And although we can overwrite a lot of things, it's bad practice. But let's bring it back to abstraction. The idea is to abstract away this code. And although it can be modified and overwritten, by using these proper conventions, like private attributes, we're able to abstract things away, but still make sure that whatever the user might be using isn't going to break our code. I'll see you in the next one.
What?
Bye-bye.
No, wait, what? Oh my god, I need to tweet about this. This is just wrong, dude. This is so wrong. No, this is horrible, bro. Wait, what? Can I take a screenshot really quickly? I want to show this. Yeah, this is so wrong. I mean, holy crap. Okay, let's take a screenshot really quickly. with my stupid face on it. Okay. Show recordings. What? What? I'm looking for an emoji. Where is the surprise emoji? Come on. Okay, let's look for it. I found it. There we go. I can't believe this shit. Why? I mean, in Java we have private, protected, and public keywords. So why didn't they enforce this? It's going to be a disaster. There must be some. Oh no, it's not. He just mentioned that you may actually override something here because you can actually override your Dunder methods. What the? This is what? 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 What the fuck? The fuck? Oh no! Oh no! This is so wrong.
A method or an attribute private, you just put an underscore in front of it, but it's no guarantee. What about this double underscore init? Again, this is something we're going to be speaking about very shortly, but it's called a dunder method. That is, it's built into Python. And we usually never write our own dunder methods. We would never write double underscore like this. These double underscores, and there's lots of them, have special meaning in Python. And the reason that they're named like this is because they're saying, hey, if you're writing double underscore for your variable, you're doing something very wrong. You're about to overwrite something. So once again, this double underscore is also a convention to let people know you shouldn't really touch this or modify this. With each data type, let's say a list, if I do dot, you'll see that as you scroll down, you have a lot of these dunder methods. Again, something that we're going to talk about. But these are here to let you know, don't overwrite these. If you're doing something like underscore underscore, I don't know, doc, like this, that's bad. Don't try and modify it and assign it to 5. So this idea of a private field is important to Python. And although we can overwrite a lot of things, it's bad practice. But let's bring it back to abstraction. The idea is to abstract away this code. And although it can be modified and overwritten, by using these proper conventions, like private attributes, we're able to abstract things away, but still make sure that whatever the user might be using isn't going to break our code. I'll see you in the next one. Bye-bye.
Inheritance, okay. I know that one. Let's see.
We talked about encapsulation, about abstraction. What about the third pillar of OOP? It's called inheritance. Inheritance allows new objects to take on the properties of existing objects. So you can inherit classes. Let's have a look at an example. Let's remove the previous code that we've had and go back to our game example. We want to create a new game. And we have different types of users. So we have users that can be wizards, that can be elves, that can be, I don't know, archers. But all these users have some common functionality, and each one of the sub-users, like wizards, elves, archers, have some common shared functionality, but then again, different maybe attacks. So using OOP, we can actually do inheritance. For example, let's say we have a class user here, and this user will have, let's say, a sign-in function or sign-in method. Once again, it's going to receive self, and then we'll just, for now, assume that we have some sort of a sign-in here. So let's just say for now, print logged in, because in order to play a game, they have to be logged in. Okay. Now, you might be wondering, where is the init method here? Shouldn't we have that init method that gets run first? Well, we could. But if we don't have any variables or attributes that we want to assign to the user, well, in that case, we wouldn't need an init method. So for now, we'll just say that we don't need, there's nothing that the user has other than this sign-in method. Now, let's say we want to create a bunch of subclasses so that we have a class wizard. And for now, we'll just do a pass here so that we don't have an empty class, but it'll still allow us to build it. And then let's say we also have a class archer that will pass through as well. Oh, and make sure we have brackets here. Now, here's the thing. Ideally, all these wizards and archers are users as well, right? So we have users, and these users can have multiple forms. They can be wizards, they can be archers, they can be ogres, all the characters in our game. But all of them, let's say, have to be signed in first. How can we make sure that all of these users or classes also have access to sign in? Well, we can use inheritance. And how do we do inheritance? Quite easily, actually. All we do is in the bracket pass the parent class that we want to inherit from.
Just like that.
User here. Now let's click run here.
Oh my god.
Looking good. And by the way, you see the green line here? Tells me that indentation is not a multiple of 4 because indentation should be 4 in Python. So we can just do this. But I like keeping it smaller just so it's easier.
Okay.
Okay, so let's instantiate a class here. I'm going to create a wizard1 and then say wizard and run that wizard class. Now if I do print here and I do, let's say, print wizard, if I click run, I see that the wizard object has been created. And what if I do dot sign in? I see that, yeah, it's actually there. If I do sign in and click run, hey, I'm logged in. How cool is that? I inherited from the user class this functionality. And this is really, really powerful because now I can extend my wizard, right? So let's say that this wizard has an init method, which will be run when the wizard is created. And we'll have a name and power that we get. And in here, we'll assign self name to equal name, and then self.power to equal power. And let's also add another method, calling it attack. And this attack method will simply print an f string that will say attacking with power of, let's say, self.power. And then we're going to do the same for the archer. So I'm going to copy this code, paste it in here.
Oh my God.
The archer will have name. And let's say instead of power, we'll say that it has, let's say, number of arrows. And number of arrows will be the new attribute that it gets. And then the attack will have, well, attacking with arrows. And then we'll have arrows left. And arrows left will just say number of arrows. And we can do something fun where the arrows decrease as Okay, so now that we have this, let's make this a little bit smaller just so you can see. There you go. Now that we have this, let's instantiate the first wizard with, let's say, Merlin with a power of 50. And then the archer will be instantiated as Robin with, let's say, 500 arrows or 200 arrows. So now the wizard and the archer are going to have, well, they'll have the sign in, but they'll also have the attack, but unique to their individual classes. And they'll also have different properties. Let's have a look. If I was to do wizard dot, wizard one dot, and then we'll say attack. And let me just turn back my code intelligence. We'll see that we have a few errors. Here, what's it say? Undefined name, self, and that's because I forgot self.
Oh, okay.
So remember, we always have to give the first
self.
If we scroll down, we go to wizard dot, we see that we have name, power, and attack. If I click.
Okay, I didn't remember that one, but he's right. He even forgot himself that when I'm creating methods inside a class, and if I want to have access to the attributes and the methods, I guess, for that same class, I need to use the self method, the self keyword as an argument, as a parameter inside the definition of the method itself. Okay.
Attack here, and I run. You see that I'm attacking with power of 50.
Yeah.
I do archer, 1 dot attack. In that case, I'll get attacking with arrows. Arrows 1. But both of these have the sign in function at the same time.
Yeah, they all.
This is the power of inheritance. We're keeping our code dry, right? We're abstracting away the part of the code that they both share, but then changing things according to what each one needs. So for example, I could have different methods and properties on wizard than the archer, but also have shared user function that they have. And this way it keeps our code.
They all share the same thing.
Let's zoom in just so you can see it clearer. Now, this idea of inheritance is really, really powerful. And the key here is that we have a parent class and children classes. Now, sometimes these children classes are called subclasses or derived classes because they're subclasses of user or derived from the user class. Let's explore this topic a little bit more in the next video.
Okay. I guess we are going to try something here. Maybe an exercise.
Now, I'm going to minimize this a little bit just so we can see a little bit clearer.
Maybe not. Okay.
And I'm going to remove some of the spacing in between here, even though it'll give us a warning, just so we can see everything. There we go. All right, so we have these classes. Now, Python gives us a useful tool to check if something is an instance of a class. And easily enough for us, it's called instance, or is.
Of?
And is instance is
is instance. Okay.
We give it the instance and then the class that we want to check. So in our case, if we had wizard1 equals to wizard Merlin with power of 60.
Okay.
If I do wizard1 and then do class wizard.
It's going to ask.
And I print this, what do you think we'll get?
True.
Click run. I get true.
Yeah, because he's
is an instance.
It's an instance of a wizard. Yeah.
Let me ask you this: what if I do user? Is wizard1 an instance of user? Guess what's
yes, true.
It's true, right?
Because it inherited. Yeah, that's
so technically, yes, wizard1 is an instance of user because we've had to run this class to create wizard1. But here is the interesting part: if I do wizard1 dot, do you see how I have our methods and attributes that I've added, but also all these dunder methods that we haven't really talked about? Where do these come from, right?
I don't know.
In Python, remember how I said everything is an object? Well, everything in Python inherits from the base object class that Python comes with, and it's called object. You see how it got highlighted here?
Yeah.
So if I do is instance wizard1 of object.
What?
Oh, and I have to remove the dot over here. Let's click run. It's true. Because wizard1 inherits or gets methods from the wizard class, from the user class, and even higher up from the object base class.
Oh, the object is the...
And that's why we have these automatic methods attached
okay.
for us. So that using object, every single method that is useful. For example, if I open up a list, if I do dot, and let's say we pick the REPR method, which we don't really know what it does yet, but if I go to wizard1 and I do dot, you see that I have it as well, because they both inherit from the object base class. And this way, we avoid repeating code. Any code functionality, I can just dish it out to all the objects that need it, which is very, very cool. So underneath the hood, when I do something like user, it's actually accepting object as the parent class in order to accept these properties that are
automatically, I guess.
Right, that was a lot. One more pillar to go. I'll see you in the next video.
Wait. Before jumping to polymorphism, I may like to exercise that inheritance, yeah. Section 6. Okay. You are going to be here. And just move. Okay. Actually, I may like to use this code over here. Okay, but first, let's just hit all of this. There we go. Let's make this a little bigger and change the date. I do have a cat class, but I may like to create a new class over here. What about the animal class? This is a classic example for the animal class. And I guess, what can I say here? Well, I guess I could ask if it's a mammal. Maybe attribute will be just fine. I don't remember how to use how to set up. Okay, I need to create the well, first I need to create this comment over here because it's so the linter is going to stop bothering me. And now let's create the init. There we go. We're getting somewhere. Okay, I'm returning something else. I wonder if I can just put this here. I guess I can. There we go. And here, I'm going to init the animal class. I may like to say, you know what, that attribute called mammal, I may like to move it back here somehow. So probably, yeah, there is an attribute here. Yeah, maybe just move it. Like here. A species, mammal. Well, actually, I may need to ask what the species is it. There we go. I'm going to add this species parameter. Is the same? What's going on? Oh yeah, because I'm not using the keyword. This one here. Now it's being accessed. Well, it's not used here, I guess, or what is complaining about? Unused argument. It is being used. Oh, wait, no, never mind. It's not being used. Yeah, it's right. There we go. So I'm creating a class called animal. I'm going to store the species here, I guess. And let's try to inherit the cat class from the animal class. Let's take a look at the well, I think I can remember. I believe that maybe here on the class definition we can just open and close parentheses and copy paste the animal class. I wonder if that's a valid syntax. Okay. Okay, it reads, now we have a, I guess this is the subject for the next video. What happens when I am inheriting from another class and both classes have their own def init method? That's going to be a conflict, I guess. What can we do here? I guess I can use the super keyword and ask for the species in the cat class, for example, and make a call here. For example, super dot init, and I'm going to pass as an argument the self dot. Oh wait, no, that's already done. Yeah, that's already done. And pass the species argument. There we go. Maybe I can do that. I'm going to try. I'm trying to figure things out here. Okay, so I am executing the animal constructor, or that's what I'm trying to do. Let's save this. See if the linter is doing something else. Okay, from base class animal is not called. So how do I call it? I don't call it here. What I can do, I wonder where may I call this? I guess that the call should be right here inside the init. This complaining before that. What I may do is to, let's comment this out. No, how do I do that? Yeah, let's move back one video here.
Remember how I said everything is an object?
Okay. Oh, now here's the issue. The user class does not have an init method. That's why he doesn't have the issue. So the thing would be maybe so I might not have an init method here. Let's try this one out. Let's try it like this. And that's it. I guess I can refer to this like well, I am assigning I wonder if this is actually a class level attribute. Yeah. What about this? Can I do that? Yeah, I cannot. But I think this is going to be a class level attribute, so maybe it's not going to work as intended. Let's try something here. There we go. Is that going to work? Super class. Super stay as super. No, I don't think it's going to work. Maybe if I do the self keyword, that actually works, I guess. Okay, so basically I give it a name, an age, and a species. I guess I can use a default value for the species. In the case of the cat, let's say known, because I don't know what the species is there, but if the species, if I'm creating a cat, it doesn't matter the name or the age. I already know the cat is a mammal, so that's why I'm doing this. So the self.species is going to be equal to whatever the species is. I guess you can overwrite this one, but I don't know. Who cares? What else? I guess that's it. Let's try to make some calls, shall we? So let's say cat1 equals to cat, and let's I don't know, let's call it Michi. 2 years old, and I'm not going to specify a mammal, which is okay because the default value is going to be mammal. Okay, and now let's print the cat's name, shall we? I have a cat name. What? Oh, wait. Oh, the wrong Spanish. Okay. And you are going to be called cat1 dot name. And has a number of years old. So cat1 dot age years old. And is, instead of has, it's going to be is. Probably is a better choice of words. Let's save it. And okay, let's create a very simple inheritance example. Let's oh wait, Python 3 space. Wait, where am I? Okay, there we go. Are you for real? Whatever. Okay, Python 3 inheritance.py. Let's try that one. Okay, I have a cat named Michi and he's 2 years old. Okay, looks like I was able to let's copy this one here and try another thing. And let's say, you know what? Let's say whatever the cat's name is, A, and let's put the species. There we go. So let's try this one out. And Michi is a mammal. There we go. Yeah, I guess that works. Yeah, that seems to work. What? Okay, whatever. Let's see. I have some updates for Visual Studio Code. Oh yeah, I forgot. I need to actually download and install manually. Yeah. Let's install that one. 82 megabytes. That's quite something. I wonder if I need to close this. I guess I should. Okay, let's wait for that one. Okay, it's finished. There we go. Let's open it again. There we go, it's installed. I'm going to read that later. Explore file nesting. Settings editor filters. Bracket pair colorization. Toggle inlay hints. Okay, I'm going to read this later today. Let's go back to the exercise. Well, this, oh, you can barely read the code there. But this animal class, there we go. That's the animal class. It's being used as a superclass or a feather class or a superclass. In order to create the cat class, I am inheriting from the animal class. But I wonder, I don't remember if this species attribute is actually, I think this is a class attribute, not an object level attribute. Yeah, because I can prove that very easily. Because if I create a second cat, and I'm going to call this, oh, I don't know, Elise. Let's say you're 5, but by some reason, I don't know, you're a fungus now. So what happens when I try to print out this? Oh, Michi is still a mammal. And actually, I may like to create a list of cats, which is going to be equals to, well, let's create the actual list, why not? To cat 1 and cat 2. And this list of cats is going to be used for a for loop for an individual cat in the list of cats. Inside the list of cats, do something. And I basically going to print the actual cat name for both cats. Why not? Let's just rename very quickly over here. Instead of cat 1 or cat 2, we may actually print all the cat names. Why not? And there we go. Okay, so this confirms, or may I say this this disproves my guess or my hypothesis. So this is a species is actually an object attribute. It's not a class attribute. I don't remember how to create class level attributes then. It's a little behind on this section, actually. Okay, so it's an animal. It's working as intended. Don't. But what happens if I want? What happens if I want to get a count of how many animals do I have on my system, on my program? Number of animals. Or total animals, maybe. And let's just start with 0, obviously. And whenever I create or instantiate a new animal of whatever species, I may like to say like the self, but it's not going to be self because everybody is going to. This is what's going to happen. Let's choose total animals plus equals 1, let's say. Okay, So, which means that if I print out in the end total animals, I should be able to print f total cats, let's say total cats equals, and here I wonder if I can do just the animal thing, animal dot total animals. I wonder if I can do that. Total cats 0. Yeah, go figure. But if I do cat1, it's going to say 1, I guess. Yeah, confirm. So what do I have to do to make total animals a class level attribute? That's the question. Let's Google about it. Python class attributes. There we go. Okay. So I want that value to be shared across all other objects from the same class. How do I do that? Okay, that's an example of how I'm doing it already. Class object class bar 1. Okay, but I do remember that there is an actual keyword. I guess it's going to be way easier to just look behind the course because attributes are here. There we go. Init, cats everywhere. There we go. Class method and static method. I wonder if I have access to... Okay, attributes and method.
We learned that we're able to create an actual attribute for the class. But what about a method? Is there a way to do something like here, what we did with attributes, but for methods? Well, there is. And we use a decorator, which is a topic that we'll cover later on, and you'll understand how these work underneath the hood in a bit. But for now, the syntax that we're going to use is...
Wait, a decorator, yeah.
@ sign, and then we call a class method, like this. So you can do some interesting things. And by the way, class methods aren't...
Maybe I need to use a decorator here too. Maybe like this. And I'm going to guess here because I don't really know. Class attribute. There is class method attribute? No. It's not. I may use class method and then def son method set yeah, let's see what's he doing here. Adding things. I guess. Yeah, I guess this could be it. Def add underscore animals. Add animals. Why not? And I'm going to, what's he using there? CLS is the class. Yeah, I remember now. It's not using self, it's using class. So maybe I can do that. Can I use this? And a species. This is object level, okay. I wonder if I can use the CLS keyword for this, which implies that attributes, okay. But I want an attribute shared among everybody else. There we go. CLS. And I don't need anything else, really. Oh, wait, I'm forgetting this. There we go. And the non keyword. There we go. What's going on? Missing function or method? What? No, you have it here. Oh, doc string. Yeah, well, I guess. Yeah, maybe I should make this, since I'm just using it to avoid being bothered by violent. Maybe just making these comments or this doc string single line makes more sense. Yeah, I don't think it's necessary to use 3 lines of text just for that. Okay, class method, CLS none, CLS total animal 0. And that should work. And I should just make a call to the add animal. Class has no total animals member. Yeah, I need to define that. Let's try to define it here. CLS dot total. No, I don't think so. Total. Yeah, but that's the thing. How do I create this as a static? Yeah, let's ask it like that. Okay. Python static attributes of a class. There we go. Yeah, methods I know how, but I don't see a video about attributes. There we go. Okay. This is a static method. Okay. Okay, that doesn't answer it. They are including both methods and attributes. That's going to make it difficult. Maybe I should just take a look in here, attributes and methods.
Object-oriented programming allows us to create these regular class attributes. Is different because, well, it's not dynamic, it's static. So if I click run here, and we want to make sure that we print something, so let's print player 2, and I click run. Well, I get the player, that's great. But if I do dot membership, and I click run, look at that, I get that equal to true. If I do player 1 here as well, and I click run, I get true again. So all the players have membership set to true, but this is not dynamic. It's a class object attribute, which means it's an actual attribute on this class. And this is something we use when there's no change. This is going to be true and exist for all objects. So you can't really modify it. It's just all the objects that we instantiate will have access to it.
Okay, so basically it is. But then again, how? Maybe the location of the increment was messing around things. Okay, wait, what happens? I am initializing this, so everybody's going to share this. This is already a class level attribute, just like that, okay? So I'm creating this class method in order to add total animals. There we go, thank you. Okay, so class level total animals plus equals 1. I only need to add, to execute this one here. That's it. So when I create this, I don't do it like this because I'm referring to my own copy of the total animals per attribute. So it's not going to be like this. Can I do it like this? No, because I'm not. But I have access to the actual class method. So I will say animal. Wait a minute. What happens if I just say self dot add animal is here? Let's make a call like this. And that should increase the animal count because it's going to run this once, and I already do the increment right here. Okay, let's try that one. Oh, wait. I'm printing a cat over here. It doesn't matter, really. I could do the animal, total animals print. And it's going to be the same thing, isn't it? No, it's not. Why not? Animal. And I'm trying to print total animals equals to 0. Okay. But if I create cat1, cat2, what if I keep adding? No, but because I'm not instantiating new cats, I need to instantiate them. There we go. Maybe not here. Maybe I can just copy the instantiation code. This is the instantiation, the instance creating code, and just copy paste it here. Like 3 times will be okay. Okay. There we go. Okay. I'm going to try this one once more, but it's going to keep doing the same thing. Okay, what is it? This tuple object has no attribute name. Oh, because it's not it's just a tuple. Yeah, you're right. I need to do this. There we go. There we go. And now we can run the code. Okay, the total cats is 0. But I wonder why on this run, what if I choose cat1 again? I should be able to get the value by just printing the actual attribute from the class itself. So I wonder why I'm not doing that. It's actually working here. If I pick the actual object and try to print the amount of animals that we are having here, it's actually working. But I wonder why. If I recall correctly, you can print directly from the class and you should get the actual value from the class. So I wonder why I'm not able to do this. What I want to do, maybe because I'm using inheritance, I'm not instantiating animal directly. I'm instantiating cat. That's right. It's not animal, it's cat. Cat, the class cat. The cat class, basically. That's what I need to do. That's why animal contains its own counter. And there we go. That's why it's not working properly. Well, I learned a lot just by doing this little exercise, I guess. So that's why if I create animal instances, I should probably be able to call this method again and any number of times, and I should have the total animal. So in this case, total animals is going to be stored at cat level. So in the cat class, so that's where cat, the cat class, contains its own version of total animals, which is different from the animal class. But I forgot that I'm just inheriting this here. Okay. Okay, I get it. Let's continue on. Oh, wait. Okay, it's 1 p.m. Let's continue. Polymorphism.
Final pillar of OOP Go. We talked about encapsulation, about abstraction, and about inheritance. And then there's this fourth one that has a pretty tough word, polymorphism. What does that mean? Well, poly means many, and morphism means form. So many forms. Now, we know that methods belong to objects, right? We use the self keyword to act upon the object that got instantiated. Now, in Python, this idea of polymorphism refers to the way in which object classes can share the same method name. But those method names can act differently based on what object calls them. Now, that sounds extremely confusing, so let's have a look at the code. We have our user, wizard, and archer classes. And as I mentioned, with polymorphism, different object classes can share method names. So we have attack here that is shared, but each one does something different based on the attribute. For example, when I do wizard1 attack, so let's do that, wizard1.attack. If I click run, I get attacking with power of 60. Because, well, wizard has a special meaning to its attack versus archer. They're different.
Mm-hmm.
So although they share the same method names, because of the object that's calling it, the output is going to be different. So we can actually do something quite interesting here. Let's say that I have wizard1, and then we'll also have archer1, and archer1 will be Robin, and Robin has 30 arrows now. What I can do here is actually call them in different ways. For example, I can create an entire new function called player attack. And this player attack takes a character, and in here we can say character.attack. And now, if I run this code and say player attack wizard1, and I run this, I'll get attacking with power of 1.
What?
If I do player attack, have archer in here. If I click run,
because it's running,
gives me a
yeah.
different output, even though we're calling the same thing because of the object that we pass into it, polymorphism. Another way to demonstrate this is if we do a for loop. If I do for, let's say, character and let's add wizard1 and archer1 into a list. And if I print here, or let's just run character.attack, if I click run here, once again, I have two different outputs, even though I'm calling the same method because of the different objects. And this is a really powerful concept, right? Because we're able to customize this according to our specific needs. Even if, let's say that the user had a attack method. And this default attack method is, let's say, print do nothing because it's just a user. Even if I run these, and let's say print wizard1, and let's say dot attack, if I click run, it's going to override whatever the original attack was because we already have that method in our wizard class.
Mm-hmm.
But let's say I wanted to have both user and wizard run the attack method. How can I do this? Now, this is something we'll explore a little bit more in the next video, but for now, I can say user.attack and give it self. Because I accept user as my parameter in here, and I can run user.attack. So let's see what happens here. If I click run, I have do nothing and attacking with power of 60.
Okay.
So polymorphism allows us to have many forms. It is the ability to redefine methods for these derived classes, that is wizard and archer. And an object that gets instantiated can behave in different forms, in different ways, based on polymorphism. And this is useful because we are able to modify our classes to our specific needs, but also not have to repeat ourselves in case we want to use something like attack from user inside of wizard. So there you have it, the 4 pillars of OOP: encapsulation, abstraction, inheritance, and then polymorphism.
Well, I have a question here. What happens when I have, in the superclass, in the parent class, I have a method, and I create another method in a child class that shares the same name? I guess that is going to be calling it's going to open the child class call is going to take precedence, and that version of the method with the same name is going to be played out. Another way of polymorphism is when the methods themselves share the same name, but they are either they have different data types in the arguments, or they on the parameters, I mean, or they have a different number of parameters, and I may like to try that one.
No amount of videos or books are going to teach you exactly when to use what. However, the idea here is to understand that these
That's
exist
cheating.
with OOP. You're never going to say, oh, I need to implement polymorphism. No, most of the time you're just coding along, and it happens that you're coding in a way that emphasizes polymorphism.
But that's not true,
This is
really.
the power of OOP. Although these are big words,
You're stumbling upon that by accident, but it does require some rules at least.
at the end of the day, we've learned how to use them to structure our code in a way that is efficient and clean. And that's the whole point. It's all about organizing our code. Now, some of you may have been a little confused when I did this, user.attack self. In the next video, I want to explore this a little bit more. I'll see you in that one. Bye-bye.
There is an exercise, okay. Okay, let's build something. Let's practice building some objects on our own and using classes. You can find the exercise and solution files attached to this lesson, okay? Yeah, let's try that. Let's see what we can do. So I have to say that this is a very loosely version of polymorphism and inheritance and everything else. Let's try. Let's show me the files basically. There we go. Okay, now can I just copy everything? No. Okay, let's copy the exercise. Okay, let's say that for the time inheritance. Okay, the inheritance pi. We're going to copy the name. There we go. Okay. Let's close unnecessary files here. There we go. Okay, let's see what happens here. Class pets, animals. Oh, I'm looking at something familiar here. Okay. There is a class called pet. Animals is an empty array. There is a constructor that receives the self object, the self reference for the object, and it gets an animals parameter that may be anything. Yeah. Self.animals is going to add. Wait a minute. Animals is plural, and it's just assigning to the array of animals whatever animals contain. So I guess that the animals parameter is going to contain a list of animals. There is a walk method for every single animal in the animals array or list. Print animal walk. Okay. Animal.walk. Yeah, I mean this one here. Okay, so here is a cat class. Okay, is lazy is true. There is a constructor. I pass the self object. I'm going to require a parameter name, an age parameter too. It's assigning basic attributes to the object. And here is the work method. It's going to return the name. It's just walking around. That's it. There is a Simon class that is going to inherit from the cat class. And it does have a sing method. And it just returns sounds, whatever that means. There is a Sally class, inherits from cat class, and sing method sounds. It's pretty much the same thing. Okay, let's see. Point number 1, or exercise 1, is going to be add another cat. Well, I guess it will be by just copy paste this. You're going to be Michi. And that's pretty much the same thing, because the single cats are new classes inheriting from that class. Okay, now create a list of all of the pets. Create 3 cat instances from where? Thank you. Create 3 cat instances from the above. Oh, okay. I guess you're going to be Simon, Sally, and Michi. Simon, Sally, and Michi. Do I need default values here? Do I have no? Let's see. Cat does have a constructor, name and age. But if I pass that, I wonder what happens. Yeah. Simon, 3. Sally, because, well, Sally in the green color is the class name. And Sally in the string, the orange string, is the actual name for the attribute name. Yeah. So 4, I guess. And 5, something like that. Okay, what happened now? That seems to be valid syntax. Okay, create 3 cat instances from the above. Yeah, okay, I did it, I guess. My guess is that since I'm sending a string and a number, but for example, Michi is inheriting from the cat class. So, and I don't see an init method here. There is no constructor inside this particular Michi class, but it does exist inside the cat class. And here it is. This is the init, the constructor method. And it's going to ask me a self, a reference to the object itself, a name and the age. And here it's going to define values that I'm sending to that particular object. Okay. 3. Instantiate the pet class with all your cats. Use variable mypets. Okay. So I need to instantiate the pet class. What do you require? I do have a... Oh, here's where I'm going to get to use the animals list parameter as an argument. So okay, let's create the pets like this equals to pets, and I'm going to pass as an argument the my cats list over here, and that should be it. Yeah. Oh, the name of the variable should be my pets. Okay. And output all of the cats working using the mypets instance. Do I already have that? Okay. There is a work method, and the for loop is already implemented here, and it's going to print out all of the animals work methods. And do I have that? Yeah, here it is. There we go. Here is this syncing method. I'm not using it, so I guess it's okay. Okay, so I guess my pets dot work, and I don't need to pass anything. That should be. I need to print this out. No, I guess that the printing is already handled by the work method. There we go. Yeah, it is. Okay. And where is the cat? There we go. And the work method for the cat class is going to do it for me. That's beautiful. Okay, so what should I do now? And this is inheritance dash exercise. There we go. Simon is just walking around, Sally is just walking around, and Michi is just walking around. And that should be it. Let's see the video. Well, there is a solution here, so I guess there is no actual video. Show files. Okay, let's read a little bit. The same thing. Okay, class. Pretty much the same thing. Yeah, I copy pasted. Instantiating the cat. Yeah, that's pretty much the same thing I did. My pets from the pets class and the works. Yeah, pretty much the same thing. Okay. Super. Oh, now we have super then. We can call superclass methods and maybe attributes. I'm not sure.
In the previous video, I showed you how to call a method from a subclass of the parent class. So in our case, we did user.attack in order to run the attack method in user. Now I've removed the attack method from now because I want to try something different. I want to create a init function in here. And this init function will take self. And then let's say that the user will receive, let's say, email. Because all the users of our game need to have emails. And in here, we'll just say self.email will equal the email.
Yeah, something.
Nice and simple. Now in here, if I was to run this code, and let's remove user.attack for now. So we have the same wizard. We just added this.
You're overwriting that.
And we have our wizard.
You just wrote.
So if I run wizard here, and let's say we want to run wizard1.email. If I click run, I get wizard object has no attributes email.
Yeah, because that belongs
I
to
thought
the user class.
is going to be called when we create the wizard, right? When we instantiate wizard 1. Well, the thing is, although we might inherit, let's say, for example, if I do dot, we might inherit the
email attribute
from the user. And if I click run, we see that we
Yeah.
inherit that. The wizard already has an init function, already a constructor, right?
Yeah.
So
That
how do we
didn't
solve this?
happen.
Well, one way is to just add email here, right? And just have the email attribute just right down here. But what's the problem? Well, it's inefficient, right? Because if I create an archer class, I'll have to do the same thing. And when we know that all these are going to be the same on all of our subclasses, we want to do it here. So what's a more efficient way of doing this?
Using the
we wanna
super
call the
keyword.
init method of the user from inside here, right? Because every time we instantiate a new wizard, well, this
I
init
tried to do that
is what we
with
call.
super, but it
So the way to
didn't
do that
work.
is to say user dot underscore init, and then give it the self, and then email. And then
That's
the
the
email
right
is something that we
way.
pass in. So that if I go down here, I can say
Okay.
merlin@gmail.com is going to be the email. So that now, if I do, let's say, dot email for wizard1, and I click run, I get Merlin's email. Once again, all we did was we called the init method of the user inside of the wizard. So when we instantiated a new wizard, we ran this function, and inside of this function, we ran the user.init and passed in the email that we passed in as an argument in here. Now, this is one way of doing it, and then there's another way, and it's called super. And it's a keyword, as you can see, it's being highlighted here. All we do is run super. And super is referring to the super class, or the class
It's a
above, which is
method.
user.
It's going to
And this is
return
actually a new addition
something.
as of
Okay.
Python 2.2. With super, we actually no longer need the self. So our code looks even clearer.
Oh,
And all we pass is this. And if we click run, we
It's the
still get
same
the right
thing.
answer. Super allows us to refer to user this way and not have to worry about passing self.
yeah. Oh, wait. And another important thing. Wait, let's pause this.
Welcome back.
Another important thing is that with super, since it's actually a method, you don't really need to learn the actual name of the class that you are inheriting from. But you can really check it out really quickly because it's right there in the definition of your child class, so it's not really an issue. But it's going to make copy pasting way easier. So let's try to do the inheritance. Okay, let's add this. Let's add this to the repo. There we go. Let's close this. Inheritance, there we go. So on this example, in the animal class, I have this issue. Well, I'm doing a class method here, but this was a workaround. This class method was a workaround because what I really wanted to do was to initialize this over here. So I'm not going to know how many. I'm going to know how many cats there are, but not necessarily how many animals there are. Because if I create a dog class that is going to inherit from the animal class, I'm going to get animal counter, cats counter, and basically total animals on cat is going to be really total cats, and total dogs is going to be another number. So the idea here is to have total animals be just that, total animals in general, no matter how many child classes are being used with the animal class. So the idea is this: total animals is going to be that. That's fine. Yeah, that's fine. So let's see. I'm going to try to create an init. Well, total animal is just fine. But the thing is, I wonder if I can use the superclass total animals. Yeah, I'm doing this. I'm executing it like this. But this is the issue. I'm going to present you the issue. The second one is going to be animal. I have any number of cats. Python inheritance.py. What? Oh yeah, I meant Python 3. So I have 5 cats but 0 animals. That doesn't make any sense. So I should have 5 cats and 5 animals. So the thing is, instead of getting this, let's see to the implementation of this. This one here, let's see how am I calling this add animal thing. Okay. Yeah, this is the issue here. Instead of this, I should say super. This is a method, and it's going to return to me the class. And here it's going to run add animal. There we go. And I'm not going to run. This is a class method. Yeah. Class animals. Okay, looks like it's going to work. I hope it works. Let's see. No, it's not working. I wonder what can I do? Because if I print out animals, oh wait, I am executing the super version. This is actually working. It's going to, but I believe that the class method, this thing right here, is only working for cats though. Okay. I'm not creating an instance of this. This is a class method. Huh. I wonder why. Yeah, I want an attribute that is shared among all other objects from all other inherited or child classes. So total animals. So this is basically total cats. But total animals is not total cats. It's 0. What I'm missing something. I wonder what. So okay, this is an attribute for the animal class, and I should be able to. So I guess this is getting the cat class is getting a natural copy. This is getting a natural copy. Yeah, I'm running the super. This super. There we go. Let's see if I can see a description here. Super any. Do I need to pass something here? Super. And then I run this class method. Wait a minute. I'm wrong. The decorator is wrong, I think. Wait, if I use class method, I might. What's the difference between a static and class method? Python. Okay, in Python, the class method decorator is used to declare a method in the class as a class method that can be called using the class. Okay, yeah. But I want to know if I can use attributes here. There we go. Yes, I can. Class name. Okay. Oh, look, this is interesting. CLS name. Perfect. Okay, so here, CLS total animals. But I'm not modifying this. I'm creating a copy for cats. And that's what's going to be modified. I'm not modifying the animal itself. And even if I replace this with animal, I don't think it's going to work. Or maybe is. Let's see. And now, did I save it? Yes. That works. Okay. So super is different from the actual name of the class. Okay, I get it now. So because super is going to return A copy of the class is not the same memory location. That's why. Oh God. Well, okay, I need to take a mental note about this. I'm going to save it like this. But anyway, maybe here I can put a note. Super. Yeah. Yeah, it's going to create a copy of the animal class. Or maybe I understand this the wrong way, but this seems to work. So in the future, when I forget about this, I can recall to this stream maybe. I don't think so. It's not really that searchable to just stream. But I'm learning a lot about how Python manages inheritance, which is really useful now that I think about it. But I really need to be very careful with Python here because it's way too open-ended. Yeah, it's not straight on its rules, and the thing that is going to ruffle me a little bit is that attributes are public all the time. So yeah. And there is if I want an attribute to, oh, you know what? Please don't modify this attribute. I do this. This is private. This is private for me. Also, I mean, wow. I don't know. Okay, looks like Pylon is going to fix my comments here. Okay, let's continue. What time is it? How long have I been here? I've been here for a while now. Let's see, an hour and a half. I guess I'm going to see what's next and see if it's going to be sensible to take a break. Object introspection. Okay, yeah, let's watch this one. It's a short one. It's a 1 minute.
I want to talk to you about this idea of introspection. And introspection in computer programming means the ability to determine the type of an object at runtime. What is runtime? That is, when the code is running, you can determine the type of an object. And it's actually one of Python's strengths. Because everything in Python is an object, we can examine, we can introspect an object and actually figure out what our code does as we're coding and then running. And Python allows us to do introspection and inspect these objects with some nice helper functions. This one function is called dir. And dir, well, if I run this, will give me all of the methods.
What the hell is that?
Attributes that the wizard instance has. So with a dir function, we give it an instance, and right away we get access to what it has access to.
Oh.
See that we have name, power, and sign in. Again, we have the sign in from the user, and then we have also attack from the wizard class. And this editor that I'm using, whenever I do dot, is actually using this ability of introspection to just list out these available methods, just like I have here. So this is really useful when you're trying to figure out what you have access to. But you need to notice something here. We have a lot of these dunder or magic methods that we haven't really talked about.
Yeah,
what are these and why are they so important? In the next video, we're going to tackle this question. I'll see you in that one. Bye-bye.
Okay, with dir, I can introspect objects. Okay. At runtime.
You've waited a long time for this because I've avoided talking about these dunder magic methods for a long time. In this video, we're finally going to uncover what they do. Now we're able to see what our instance has as methods using the dir method. And we told you that these were inherited from our
methods. Okay.
Now, these underscores are special methods. Remember how we have things like length, for example, that allows us to tell the length of an array. These are actually implemented using these dunder methods. They allow us to use Python-specific functions on objects created through our class. So let me show you what I mean. We're going to create a new class. And this is going to be a toy class. Now, in here, we'll define a toy and initialize it with self. Then we'll say that it has color and age. Now we'll say color equals to color. So these will be our attributes and age. Awesome. There's our class. Now, let's say we want to create an action figure. This action figure will be instantiated with toy, let's say color of red, and the age is, it's brand new, so it's 0. Now, if I use something like, let's say, str that comes with this object, if I do str, or action figure, dot, underscore, underscore, str, like so, and we print this, we see that we get this. It's the exact same thing as us doing str, action figure, like this. Look at that. These double underscore dunder methods are special methods that Python recognizes. For example, the dunder str, this special method, allows us to use action figure like this using the str built-in function. As a matter of fact, if you go to the Python documentation under the special method names section, you'll see that we can do basic customizations of these dunder methods. And it's a long list of all these dunder methods that we can use. Now, don't go and read every single one of them. There are a lot, and you're not going to use them that often. There's only specific few cases that you're going to use them, and the idea is to know how to modify them and how they work underneath the hood. So let's go over a few examples. For example, let's modify what the str does. I'm going to define my own str here. I'm going to call self. And then in here, I'm going to return something different. I'm going to return, let's say, an f string that is, let's say, self.color. If I run this, I get red. Remember how I said not to modify dunder methods?
Yeah.
Sometimes you're allowed to. Maybe there are cases, special cases, where you want your class to behave a certain way. Just like dictionaries, lists, tuples, and all our objects in Python can behave in certain ways. How lists were accessed with an index and a dictionary was accessed with a key. Those are all implemented using these dunder methods. And you see here that because we modified this, the str now returns red when being called on action figure. It doesn't change things other than within action figure. If I run this, you'll see that it still runs action figure like this because this is a string. The str is only modified when we use it on this specific object. Like so. What other neat things can we do? Well, we can change the meaning of the length as well. So length, I can say self. And then here, I can just return 5. Now, if
all the time
length of action figure, and I click run, I get 5. Very cool. By the way, if this underline is getting a little annoying, which frankly, for me, it's getting a little bit annoying, I'm going to click on settings here and just remove code intelligence. So it won't tell me when my code is wrong.
Wow.
We can just debug it ourselves.
Okay.
So there we go. We've just changed the length dunder to return 5. Let's keep experimenting. We can also do something like underscore underscore delete. And delete, well, let's just actually use the delete keyword, which we actually haven't seen before. Delete, we can just say return deleted. You have to go like this, and let's just do print here. Print deleted. If I click run, I see that I returned deleted. Now, the delete keyword, I haven't really taught you because it's not something that you'll see a lot of. Usually, this can cause some funny bugs in our programs that I like to personally avoid. But the delete keyword deletes some sort of variable that we might have had in our program.
Okay.
Right, what else is there? Let's change this to use something called call. And call is an interesting one. Let's say that with call, we're going to return, and let's say yes, question mark. The neat thing about call is that now it gives our toy class some superpower. We can say action, figure, and then say, well, with call, we actually can now call the actual object with these brackets. So using call, I have this special way to call a function, which by the way, underneath the hood, the way we're able to call functions is using this dunder call. If I click run, I get yes.
Like a function.
Right. One last one, because I think you're starting to get the idea of this. Like I said, these are all available in here. Usually you don't want to overwrite them, but you just want to know that you have the power to do so if you choose. The next one is called get item. So let's do define get item.
Okay.
And we're going to use self as the first parameter, and then let's say I for index. And in here, we'll return self dot, and let's add an attribute before we add that. I'm going to say self dot my dict for my dictionary, and then add name equals to yo-yo, and let's do has pets equal to false.
Okay.
Now, using this, I can say my dict and return the item based on the index that we give it.
Okay.
So let me show you what I mean. If I now do print action figure dot, and
get item.
instead of doing the dot, we do the square brackets, just like we would access perhaps getting a dictionary item. We can now, using the get item, say what properties do we have? Name. So let's say name. And if I print this, forgot to add let's try that again. And if I scroll down, you can see I'm really good at reading errors. Name action figure is not defined because it's action figure. Not figure.
Okay.
That's better. Look at that.
There we go.
Yo-yo was being able to access using this bracket notation, using the get item dunder. Very cool. So these special magic methods are really interesting because it allows us to do some custom modifying of our classes. And you can also understand how in Python, our built-in default types had access and abilities to have all these special syntaxes. We now have that power as well. Let's take a break and do a bit of an exercise.
Yeah. Extending list. Okay, let's see.
I have a fun little exercise for you. I want you to create a super list using the class super list. Now in here, I want you to add code that allows us to have, just like we have a list in Python, allows us to access through index, through, any way that a regular list allows us to use it. But the only difference is that the super list is going to have a special dunder method. Let's say that when we do length, so when we define dunder length, we're going to modify it and we're going to have it return no matter what 1,000. Now, this may look easy because all we want to do is modify the length dunder here. But the question is, based on what you learned about inheritance, about object-oriented programming, instead of having to write every single dunder that we need to use on a list, how can we easily acquire the power that list already has and then just modify this length dunder? So remember, superlist is going to be a list that we can create. We can instantiate like this, superlist1. We're going to call super
list.
And it's going to allow us to do things like length, superlist, and also access items in the superlist or use superlist 1 dot, let's say append, and maybe append 5, and actually get super list 1, 5. All right, take it away from here. Give it.
Okay, let's pause. Thank you. Well, this is a modification. Let's see, what did I modify? I added a comment. And okay, I remember now. Let's copy the relative path. Okay, now yeah, something like that. Yes. Yeah, it doesn't really matter that much. There we go. Now, this is going to be superless.py. So what he's trying to do is, what I will do is two things. One, inherit superlist from list, and then two, return 1,000 as the definition of length. So let's see, class superlist. Class superlist. And you are going to be inheriting from list. And length. There we go. Whoa, looks oh, that's interesting. I'm going to it's actually writing out. Well, in this case, I'm going to return 1,000 all the time, so I can just do that. And let's try to run this. It's going to instantiate superlist with super_list1. It's going to be equals to superlist, obviously. What else? Semicolon, that's weird. Len superlist1, okay. Let's print that out. Len superlist1. That's the first print. Superlist append 5. Okay. That's a method that I should have been inherited. Append 5. And then superlist index 5, I guess. Well, I may like to print again the length of superlist length is going to be 1,000 always. But I guess print. Okay, let's do that. I call print superlist1 index 5. Let's save this and superlist. Something is wrong. It says okay. It reads print superlist 5. List index out of range. Oh yeah, I forgot about it. I cannot print 5 directly. I am out of range. Maybe I should do this. Yeah. There we go. The length is 1,000. The first element is 5 because I just appended 5 to the list, to the super list. Okay, so I guess that's how the solution is.
Pause the video because I'll give you the answer. So let's just implement this. We're going to have self in here. And
oh, I forgot about that. No, I didn't.
So okay. When we call superlist 1, and let's comment this out, and I do length here, let's print it out, I should get 1,000. That's good. But I want the functionality of this. I want to be able to append to my superlist. So let's run this and see what happens. I get an attribute there. Superlist object has no attribute append. let's think about this. How can we acquire the powers that lists in Python already have? Well, we learned about inheritance. Right?
From,
all we have to do is just simply type list. And now list becomes our parent class of superclass. So let's give this a go now. If I click run, all right, that seems to work. What if we want to access superlist at index, well, not 5, at index of 0? If I click run, I get 1,000. Well, that's because we're not printing anything yet. So let's print here and click run. Check that out. We're able to have this superlist, and we just extended the functionality of list. How cool is that? Now to double check, there's a fun little function that we have in Python, and it's called is_subclass. And here we say superlist and list. If I click run, I get true. Because is superlist a subclass of list? Yep, that's true. What about this? Is list a subclass of the base object?
Yeah, true.
Yep, it's true. Remember, everything in Python is an object.
It's an object.
That inherits from the base object class. You then inherit.
Just like in Java, the same thing.
And we're able to use all of that in our superlist just by inheriting like this. Very, very cool. Now, for some of you, this might have been a simple exercise and you got it right away. If you didn't, don't worry. Now you know. Pretty cool, eh? I'll see you in the next one. Bye-bye.
Yeah, that was pretty simple. Multiple inheritance. Oh my god.
Let's talk about multiple.
We're about to get into C++ mess over here. Let's see
which
what happens.
we're able to do in Python. Now, remember we have our user, wizard, and archer classes. We're trying to build that game, right? Now, let's clean up some of this code. We won't need the init function anymore. We'll just have user here. We have wizard that inherits from
wizard archer
that inherits from user. What happens if we want to create a new character?
A ranger.
This character is called a class, let's say it's called Hybrid Borg. A weird name, I know. But here's the thing. Hybrid Borg is a special type of character because it has the powers that wizards have, which is attack. It has the powers that archers have, which is check arrows. And just for fun, let's also add run here. And we'll just say
run
really fast. All right.
Okay.
So we want this Hybrid Borg to have all of these methods. Can we do that? Well, we can. All we need to do is say wizard and then archer. We can give it as many parameters as we want as multiple inheritances. We're inheriting from wizard and archer. So that in here, let's say I don't do anything and I'll just hit pass. If I instantiate, let's say Hybrid Borg 1 is going to be Hybrid Borg class instantiated. I can now use all of these things. Let's check them. Let's say print hp1.run. Can I do that?
Okay.
Spelling error. Let's make sure it's hybrid Borg, not hybrid board. I hope you're not bored of this video. All right, I get an error. Missing 2 required positional arguments.
Yeah, name and power. But why not
these things in, right?
But why not name and arrows?
Okay, so let's say that we want name to be Borgy and the power to be 50. If I run this, all right, it looks like ran really fast. Run works. I was able to inherit from archer. What about check arrows? If I click run, I get Hybrid Borg object has no attribute arrows.
Ooh,
now, why is that?
That's an
because
issue.
Technically, we inherited from wizard first, then archer. And wizard accepts name and power, but we never gave...
the constructor never ran.
So how can we solve that? Let's try something.
By creating a constructor.
Would this work?
No, you need a constructor for Hybrid Borg.
With multiple inheritance. And why some programming languages actually don't even allow multiple inheritance.
Yeah, because it's a mess.
To make sure that you understand how these are implemented, to make sure that we're not overwriting anything. In our case, we can complicate our code a little bit. So
yeah, a little bit is an understatement.
I can perhaps do something like this. I can say define
a constructor.
This receives self. It will receive a name, a power, and also
arrows.
And then finally in here, I can say that we're going to call also the archer.
Oh my god.
Dot init. And that's going to take self and then pass in the
name and the arrows. Okay.
So that if I run this, well, let's add the arrows 100 here, and I click run. There you go. Arrows is now working. Now, just to check, our attack on the wizard is working as well. If we do attack and click run.
Yeah.
Oh boy. Now our hybrid object has no power. So once again, in order for us to have power, we'll have to copy this.
Yeah.
Wizard.
Self, and run the
power. If I click run. All right. Attack works. Let's go back to check arrow. Make sure we haven't broken anything. If I click that, that works as well. And then finally, what about sign in? Will sign in work?
Yeah, everybody, because you already inherited.
Right.
Yeah.
Oh boy, that was a lot. And there are a few ways of actually solving this problem. What I wanted to show you, though, is that when you do multiple inheritance, things can get complicated.
Yeah,
walk through it step.
It's going to be a mess.
There was a coder that came along on your team at work and tried.
But you have the option, so I guess it's okay.
And things are getting more and more complicated.
Yeah.
Keep track of everything in your head. And this is why multiple inheritance is one of those things where it's really, really complicated.
Yeah.
With great power comes great responsibility because we're creating more and more complexity. Again, part of the reason that some programming languages don't actually allow you to do multiple.
Yeah, they don't even allow you. I think Java doesn't allow you.
Video, we're going to talk about something called MRO.
C++ allows you.
Great example of why you want to be cautious with multiple inheritances. I'll see you now. Bye-bye.
Method resolution order. Oh my god. Yeah, because of the stack.
Well, let's talk about something that sounds quite complicated. It's called MRO, or method resolution order. What does it mean?
It's a stack.
Here for you. Let's say we have a class of A, class of B that inherits from class of A, does absolutely nothing. And then we also have class C that inherits, again, from A. And then finally, a class D that inherits from B and C. So we have two classes that do absolutely
C.
nothing.
Oh
and
my
a
God.
class A and class C that have the same class object attribute.
Oh God.
And I've actually drawn out how this relationship looks like. You see that D has multiple inheritance from B and C, and B and C inherit.
They all inherit from A.
And MRO, or method resolution order, is a rule that Python follows to determine when you run a method, which one to run. We have such complicated inheritance structure. MRO is a rule that says, hey, do this, and then do that, and that's the method that you should run. Let me show you what I mean. Let's say I wanted to do print d.num.
Yeah, which one is going to have?
Move this out of the way, or comment this out.
1?
If I run this, can you guess what's going to happen?
1?
If I click run, I get 1.
Oh,
Is that
yeah.
what you expected?
Yeah.
Look through this. D inherits from B and C, and then those inherit from A. So
Yeah.
we get 1 because the MRO, the method resolution order, is that it doesn't go D, B, A. Instead, it goes D, B, C, A. Let's think about this a little bit more. MRO is simply saying what's first in line. If things are common between classes, methods, or variables, or attributes, what should I pick? And there's actually a good way for us to check this. If I do MRO and then run it like this.
Oh, I don't have to calculate it in my mind just like now.
This is the order, or the MRO.
Oh,
of
the
this class.
resolution
It says, hey,
order.
I'm going to check D first. If you call, let's say, D.name. or
Method
D.num,
resolution order.
I'm going to
I get it.
main.d first, so I'm going to check this
Okay.
one. Then I'm
It's
going to check
going to be
main.b, so I'm going to check
main.b.
B, and then I'm going to check C,
C.
and then I'm going to check A, and then finally I'm going to check the base class object. Again, we've seen that before. It's the base class that all objects in Python inherit from. So that's the order that it checks. For now. If we pass all of these, and I click run, I'll get an error. D has no attribute num because it went through all this path, even checked the base object.
Yeah.
Never found
There is nothing.
I did something like str. If I click run,
It's going to find
this
str.
works because it goes all the way through the inheritance chain and then gets to the base object, and the base object actually has this, so it doesn't error out. And yep, you can use the dunder string. Now I found a great example here to show you why inheritances can be confusing and why things like MRO you might
But
want
that's
to
a great
or
tool
at least be conscious of.
because
So
I can
copy this
figure out. At least I have the option to figure out.
This,
Oh
and we're
my
gonna play a little
God.
game. Now this
Okay.
syntax looks like this. So this
Oh
is the inheritance
God.
of what we just created. Looks pretty confusing, doesn't it?
Yeah.
So if we do M here, and we check the MRO or method resolution order
What
of
the
M,
hell? A and B and
the order is going to be
multi-inherited
positive here
and
and
M
try
is a
and
mess. That
Ready?
itself is
let's do
multi-inheriting
dot
from,
MRO.
I don't know.
And by the way, another way of doing this is to
Oh,
use the dunder MRO.
Oh,
and
it's a
let's
thunder.
print this.
Okay, print.
All right, let's check.
Oh my God.
So the first thing we have is M. All right, we check
It's
M. And then we check B. We check B.
B.
All right. And then we check A. So we check A here. And then we check X. X over here. Then Y.
Okay.
Then Z. Then the class object. Is that what you guessed? Let's look at the code.
Okay, so it doesn't
Why?
travel back
Well,
several
the order
times,
is because
just
of the way that
once.
We're passing in the parameters. You see, B
Okay.
is passed before A and C. So that means the order of MRO is going to be B, then A.
B,
But hold on. After B
A,
and A, what was that?
C.
After B and A, we have class X. Why did
Class
X
X,
come
okay.
before Z?
Yeah,
So instead
why?
of going to Z, let's make this
Oh, it's going to resolve the
Z,
path
it goes to
from
X, then Y,
A
then Z, then the
first.
This is because of the
Okay.
algorithm that they use for doing MRO.
And it's going to skip it.
Now, this is beyond scope, of course.
Oh,
As
okay.
you can see, it's quite a bit confusing.
Yeah,
Now,
because
as a matter
it's
of fact,
no,
Python
it's not
actually changed
confusing.
the
This
MRO
is
rules from what we have previously
research
in the other versions of
algorithm.
Python.
Yeah.
So this is another one of those things that got updated.
Yeah,
The reason I'm
yeah,
showing
it
you
makes
this is because
sense.
You're never going to get tested on this stuff. If you're writing code where the inheritance
well,
looks like
no.
this, I argue that you're writing bad code because
No.
this is overly complicated. We haven't even written
Yeah.
code actually inside of these classes, and it's already confusing.
Yeah, you're
MRO is
searching
a
inside
way
the
to
tree.
define what
It's
order
a
you're
it's
gonna inherit,
a
and you can always use the
tree
MRO
search
or
algorithm.
dunder to check this. But the reason I brought it here is not just trying to confuse you. The reason is that it exists. However, you should
Yeah.
not structure your code in this way.
No.
This doesn't mean that this doesn't happen in the wild. Yes, it does. But you
Yeah.
have a way of checking and maybe debugging your code when you see a problem like this.
Yeah,
I'll leave
I
a
need
resource
to
for you
debug.
with MRO
And
if you're really curious and you really want to understand
with
how this
MRO, I
algorithm works
can
and how this order
debug it
The
easier.
key takeaway is that this is the way that Python works to determine, hey, when you call a method or an attribute,
What's going to
is
happen?
how I'm going to look up the hierarchy
Yeah.
of inheritances. All right. If your brain hurts, don't worry. So does mine. Take a break. And I'll see you.
No, it's fine. Actually, it's going to work great because MRO is my method resolution order.
Programmers, we
Wait, what? This is another chapter, bro. Wait a minute. Oh, it just skipped to the next one, to the next chapter. Okay, I guess I finished chapter 6, object-oriented programming. And next one is, oh my, functional programming, advanced Python. Wow, that was a lot. I'm going to forget about the last videos from section 6 because they don't really multiple inheritance. I like to keep away from that, but I might end up using multiple inheritance just by the fact that that I'm going to be using other people's code and other people's libraries, and those may already have multiple inheritance with MRO, which stands for multiple. What was the name? MRO, method resolution order. There we go. Then I actually know the order of the stack that is going to run. So I get the stack, so it's not going to be a surprise of why I'm not getting the value I'm expecting. I'm going to be using method resolution order a lot during unit testing. So I already know I'm going to be using this to debug and create my tests. Okay, for right now, I wonder if I'm going to continue streaming. Maybe not right now. Wow, there are a lot of sections left to do, but I'm way deeper now on this course. Functional programming. What is functional programming? Pure functions, map, filters. So we just got a section of object-oriented programming, and on the same programming language, we do have functional programming itself, which is another paradigm. So whenever I'm more like an object-oriented guy, functional programming, I know how to do that, not in Python, but I've been doing functional programming a lot. And it's going to be very flexible to have both paradigms. I will not like to mix them because it's going to be very confusing already. But I think it's great. I'm going to take a break and probably play some video games, check a work email because I'm expecting some feedbacks from my email, and continue later, maybe today, with this course. Thank you for coming in. See you later.